he's at home sick, and it has been sick for a while, and he just came back. I have a quick message from him. This would be nice, probably, if this works.
Hey, so yeah, I'm not there or here, and I can only send my sincerest apologies. Not super well right now, but the talk that would have been scheduled in this slot was how I learned to love React. There's slides and a video already online of that talk, of me delivering that talk in Italy, so you can look that talk up and go crazy. The talk that will be given instead is Ludicrous, Reaching Ludicrous Speed by Matteo. And this is actually going to be more awesome because, well, I've been working with Matteo on sort of researching JavaScript and Node performance, and we've put a lot of that stuff into practice, into tooling, into the Pinot logger and different things, and there's a lot to benefit from what Matteo knows. I mean, I know I've benefited a lot. So enjoy. If you're into React or you're interested in React, then you're interested in JavaScript, and this is going to be very interesting. Enjoy.
Thanks, Dave. Hey, Dave. Thank you. I'm sorry. We are all really sorry. This was a last-minute decision from yesterday evening, and basically we decided, the organization, what should we do? Should we leave the slot empty? And we decided not to. So, reaching ludicrous speed. So this is a bit of a journey, and it's my journey. And in fact, well, we can say that light speed is too slow. And, well, we want to be fast, OK? I don't know, how many of you have seen Spaceballs? The others, I think it's on Netflix, probably. So go down to Netflix or to Peerflix, I don't know, I'm not saying this, and have you to look it up, watch it, it's really funny. Anyway, it's a fun moment about ludicrous speed. Well, this journey starts back in 2013. I was at Node.conf. By the way, it was a great conference. We rented a full castle over there, and we sticked a lot of people in the castle. Anyway, well, this was me there, still there at Node.conf 2013. And in 2013, I was speaking about giving this talk. It's still on YouTube, still actual. What I'm talking about still works. Maybe a couple of deprecation warning. So I was speaking about MQTT and Node.js. Well, I presented this open source library, which is called Mosca, which doesn't really matter for this talk. And it's an MQTT broker. You may not know what MQTT is or not. Don't care. It's just a publish-subscribe broker. And it's written in Node, it's open source, MIT license. And it is fast, as I claim it is fast, for 20,000 publish per second. You can send 20,000 messages on this broker per second. I claimed it was fast. It was highly CPU bound, not IO bound. So, well, whatever. So is this fast? I thought it was fast. The other ones were not crazy faster than this. I thought Node could be faster. It should be faster, right? Why not? Is Node slow? Is Node fast? What does fast mean? So I went down the rabbit hole of performance optimization. That was 2013. Now it's 2016. So a bit of time happened, and I actually learned a lot. And, well, I set myself on a quest to achieve a 10 times performance boost on my MQTT broker, which means 200,000 messages per second from 2013 to 2016. Tools that I've tried. This has been 3 years, almost 3 years and a half of work. I presented this in November, so it was 2 years back then. So tool I tried, well, first of all, I tried flame graphs. To generate flame graphs back at the time, we needed to use Solaris on Giant Cloud. How many of you have ever used Solaris in your life? Great, guys. All of you. How many of you found easy to generate a flame graph? OK. So yeah, well, to generate flame graphs, you need to use dtrace, which is a bit of a pain. It also works on Mac, kind of not, but yes. I also tried doing some magic things with MDB. Forget all of that. What worked for me was just these 3 options. And reading the metrics. That was the problem, half of the problem. This option gives you tells you exactly what's going on in your application, but it's really hard to read. So, well, we'll present at the back of the talk some more tools to help you out. So let's discuss first of all how Node works. Node works with a nice event loop thing. There is an event queue thing where events are queued up. And events can come from a nice asynchronous I/O thing, which means the kernel, Linux kernel or Mac kernel or even Windows kernel is truly asynchronous. It notifies our process that something has happened. Or there is a nice thread pool for stuff that can be processed asynchronously. So, well, in order to get faster, means we can do more I/O. I don't care at all about CPU. For me, faster is doing more I/O. So it means in theory, if I have a 800 megabit pipe coming down to my virtual machine, to my server, I want to be able to squeeze 800 megabit of data out of it. Because that's the bound, OK? There is a limited amount of bandwidth that your server can handle. And once you reach that limit, who cares about CPU? OK? You need to have enough CPU power to reach that limit. However, you can be CPU bound. So it means that when you get an I/O event, you need to process, you remember the event loopy, and you process that event and you release the CPU as quickly as possible, because then there is the next one. Node.js executes one event at a time, so you need to be extremely quick. There's a queue of events to be processed. So it boils down to write very fast JavaScript code, full stop. Because you need to release the CPU as quickly as possible. So this is where the CPU is important. This came down to then, given the fact that we need to execute JavaScript really fast, we need to execute code, we need to use V8, we need to learn how V8 works. V8 is the engine of JavaScript inside Node. It's the virtual machine. It's also in Chrome, so whatever I say in this talk, it's also valid in Chrome, and possibly in Firefox as well, kind of, and also in other browsers as well. So V8 can optimize our functions. Nice. Also Java, the JVM, or whatever, can optimize those functions. But only when they run enough time. So you have a function, it gets hot, then it gets optimized. My problem in Moscow was naive. I was allocating a lot of functions, shitload of them. Hey. Most of them anonymous, and this was the output. You remember the magic flags? The magic flags tell you that a function is being optimized. Most of my functions were anonymous. That thing was what was happening all the time. This was the output. Does this tell you what's happening? Is this, if you read this in your piece of code, can help you out? Nope. So, well, this is my enemy, in fact. OK? if you allocate a lot of these, it's not going to be optimized. There have been a lot of for this was really true for in Node 10 and 12. Right now, with the latest V8 thingy, it's a little bit better, but not that better. Anyway, this was not being optimized. So let me show you some little piece of thing. Oh, I didn't show you. Yes, OK. So first of all, let me show you one more thing. So I set myself on the 10 thing cast to achieve 10 per benchmark. So this was the previous this is the previous version of the stuff. Whoop. And the previous version, whoop, Node, just been. This is the previous version of my broker. And let's bomb it. And can you read it, right? So we run our. No? Can you read it now? Yes? OK. So you see it's ticking roughly at 23,000 messages per second. This is a new code base, mostly rewritten, because, yeah, well. And this is a new one. And the new one is ticking at 207,000 messages per second. And it keeps being there. It just goes. So this stuff works. It's the same thing, does the same thing, actually. Like, so, well, let's make some more. Let's show you what the problem is. So let's do the very simple thing that MQTT, that a public subscribe broker needs to do. It's calling functions in parallel. So I send a message to you, and I'm a broker, so you can subscribe. It's an event emitter. And I need to call these functions in parallel, OK? Have you ever used a sync.parallel in your life? Yeah, probably. Hopefully, all of you. It's basically the same thing. So I wrote this little parallel function. And by the way, this is how async works. And I have a list of tasks that are functions, and I call them one at a time using a for each loop. See the function. And then I call the function, and when I finish doing it, I call count. I call done. My asynchronous function is just set immediate, just because I want to pass it through the event loop. And I run it, and I bench it. And let's see how this perform. So my naive script is quite. So you see, naive is definitely slower than set immediate. It executed 1 million times. It's still crazy fast, but it's a little bit slower. So let's do it a little bit better. If we can do it better, well, we can note, well, if I know that allocating a function makes my software slow, then I can avoid iterating using for each. And I can just use a for loop. Magic, a for loop. OK? I'm just using a for loop, and I'm just allocating one function and not for the wrapping. So I'm allocating roughly n function less than before. And let's run this. And running this, you see naive, well, this is naive faster, and then it's set immediate. So by removing the function allocation, I made my code roughly 10% faster. OK? Now, can it be better? This is a really crazy amount of code. So this is my new parallel function. I even removed that single function allocation at the bottom. How did I do it? I'm creating a queue. I'm recycling the function. I am creating a queue of functions to be reused to avoid allocating new stuff. I use this. This is a nice pattern. And let's try it. I'm not going to just use the code. The code is online. You can see it. Yes. See? It's almost as fast as doing nothing. it's almost as fast as bare bones set immediate. Okay? It depends really on the run because the difference becomes so crazy that it's not always there, but it's definitely there. This technique, I bundled this technique in a module called Reusify. You can see Reusify here. And Reusify basically automate all of that. You create a pool of function with Reusify, and you need to pass it a constructor, which basically wraps the function in which you can recycle the function and attach some state to it. The problem with allocating functions is the managing state, is the closure point. So when you locate a function, V8 and whatever interpreted language needs to bind the closure to the function. So in order, if you want to recycle it, you need to attach your state somewhere. And by using V8 hidden classes and some more magic, we can make data operation really quicker than what V8 could do by itself, detecting the full closure context. So what happens with Reusify, I should have roughly the same performance of the no allocation mode that I did before. Yeah, roughly. It comes out faster. So anyway, let me see you one more example. How does this apply in practice? So I wrote this nice example using map. So I use well, you probably know async. So this is the async equivalent. This is async.map. So you want to map asynchronously an array of stuff to some other. And in this particular example, well, we are just doing a multiplication and calling setImmediate. Really quick thing and stupid to some extent. But there is and then we are accumulating all the results. So I'm benching this with async, neo-async, and Steed. Steed wraps Reusify and some other libraries to provide an async equivalent using this technique. So this is the difference, and is kind of outstanding if we go it. So this is Steed, is 3,000 milliseconds or something. Time is passing. This is async. And then we got Neo, which is kind of in the middle. And yes, it goes lower because it's recycling its own functions. So if you've been using async in your code, you now know how to make your stuff faster, quickly. So in fact, well, these are the examples are on GitHub. In fact, this is all the benchmark results run for a very long time with a laptop not connected to the internet, with no projector attached to have the lowest, the small, to not have any interference running the benchmark. And this is what it is. And it comes out that the fast parallel is what Steed uses. So it is fast. So this is my module, Steed. You can try it. It bundles fast parallel, fast series, fast queue, whatever you can imagine. The trick on Steed, let me show you here. In map, the trick in Steed is you use a state. So you can, if in all the function in Steed, you can pass in a state object. And with a state object, you can avoid allocating a closure for your processing function. So, which means you can avoid allocating any function for doing, and you can avoid allocating any closures. Which means all your functions can be highly optimized by V8 while they run. And this new thing here is the major difference between Steed and async. If you don't use it, it will still work, and it will still be faster, but not as fast, not as crazy fast. So, well, in Steed, we have some more stuff. We have Steed each, Steed map, each series, map series, parallel series, waterfall, queue. So, just to recap, some rules for hot code path. And first thing, which yeah, first thing, do not allocate functions. Yeah, but it's kind of the purpose of JavaScript, so we can't usually avoid that all the time. And make sure that V8 can optimize them. I haven't not touched this subject. This is a subject of its own talk. There are things called V8 optimization killers. You Google V8 optimization killers on Google, and you find out what it is and how to write fast functions. If you put a too big comment, your function won't be optimized, for example. But that's only one thing. There is a bunch of those. Remember then, if your process is running 100% of CPU, everything is hot. You can't run faster than 100%. So even if it's something, it's not in the hot code path that's eating most of your CPU, whatever you are executing is actually executing slowing your hot code path. There is a missing bit. There is a garbage collector, and it's which is a tricky bit. And the problem on my broker and what was the final bit of improvement, in most cases, was allocating a buffer for each packet. And unfortunately, and copying all the relevant information. So I had one buffer. I had a lot of small buffer and strings to create a packet. So I was copying stuff over all the time. Which then will mean all to be collected. So I'm basically duplicating the garbage collector job. So I rewrote the packet generation to be a streaming packet generation. So instead of writing all the chunks of my packet to copying all my packets, I started writing all the small chunks as they were into my stream. I also started, given that now I could put small chunks into my stream, I could also memorize headers. There were some headers that were common, so I could start memoizing them. So to avoid allocation. The trick was possible because of two magic things, cork and uncork, that are present in the stream API, and avoid crossing the JS C++ barrier too often if you write a lot of small chunks. By the way, because this cork and uncork trick is being used by HTTP server that you are using. So when you are sending any HTTP headers out in Node, they're using cork and uncork. So take into account that this garbage collector stopped the word. Well, yes, avoid allocation as much as possible, probably. From time to time, it's faster to have slow code that does not allocate, fast code that allocates. This is kind of weird, but it's the hard truth of garbage collection. Well, in this journey, I hit a major roadblock. I wrote all my software and all my functions to be optimized and reused. So it's not creating any output. They optimized the thing is completely empty all the time. So, but I was still seeing a nice anonymous function being created all the time. What? Where that is? So we went in a big debugging session with Dave, the same Dave as before. We loaded the stuff on a Solaris machine, fired up MDB, and tried to hook down that anonymous function. Took us probably 5 hours to get the MDB stuff running and 15 minutes to get the answer. The problem was in Node itself. So, well, there was a performance bug in Node, and fixing this made your stream run between 5 and 10% faster. In my case, it was the last 10% of performance improvement to pass the 2000 mark. It's a nice pull request. You can have a look. It makes also your HTTP stream faster. And this is part of Node 5.7, and this is also part of Node 4, since Node 4.4. So you can try it. It's already there. If you measure it, you will see probably a different, and it's also part of 6. Remember, one rule: it's perfectly fine to write code that is slow. Not all code needs to be fast. I was doing a training course on performance in February, and some friends of mine, they wrote things like not thinking about being fast. We did a training course on performance, and they told us, well, we were able to reduce the numbers of servers for our system to 1/3. Make the math roughly. Well, I did all of this by hand. It was not easy. There is a nice tool called flame graphs. Unfortunately, to generate flame graphs, you need to have a Solaris box. It's a big chunk of work. So, well, we automated this. We wrote a tool called perf that allowed us to generate flame graphs on Mac OS X and Linux easily. However, even this tool was crappy to use. It required 3 different terminals and so on. And in fact, well, I'm not saying the demo. In fact, my demo is about 0x. And 0x, it's our latest generation thingy. So instead of running my server with Node, I run with 0x. And yes, and I need I need to put sudo because it requires dtrace on Mac, while it requires perf events on Linux. So we are running it. You see there's a little performance drop. And, well, we kill it because I don't have much time to spend on running my benchmark. It generates the flame graph. It's generating a flame graph. Now we can open this. And this is my flame graph. So this has been generated on a Mac live on stage. Now, you see these might look like a normal flame graph. However, it has some very clever things here. First of all, it can tell you if a function has been optimized or not. You can click on a stack and see all the stuff. OK, now, this has been optimized, but not all applications have. Then you can also see if you are spending stuff on V8, for example. And this is all the V8 things. If you don't want to check core, you can avoid core. Ouch. OK, this application is particularly fast. And you can remove dependencies. And you can also check if a function is anonymous. I don't have any anonymous function, as I told you here. But even if you have an anonymous function, you will see where the function was allocated, because there is a full path of setting here. And you can also search. For example, we can search for release, and yes, it's working. Oof, kind of. It's probably crashed Chrome, but don't worry too much about it. So yeah, so this is 0x. Well, this is not really relevant, but Dave mentioned it in the intro. So check out Pino. Pino is a really fast logger. Well, it's a lot faster than alternative. If you are using Winston in particular, I'm sorry, Charlie, but yes. Check it out. It's 17 times faster than alternatives. If you want to if you're logging a lot, there have been people using this that took, I don't know, 20% improvement in their app just by switching logger. Oh, and I wrote a fast HTTP load testing too in the process of craziness, which is called autocannon. And this is autocannon. And yep. So let's start a very dummy server. And by the way, this dummy server is this. Okay. So we can use autocannon, specify some concurrency, specify some HTTP pipelining, and run it. And this will give us some result. By the way, if you don't know about HTTP pipelining, look about HTTP pipelining. It can make your app much faster. And these are the results. Well, this number here is completely wrong. I don't know what's the problem here. I need to fix this bug. But here is the right result. Now, look at this. This is Node 4.4.2. Let's switch to Node 4.2, which doesn't have my patch. And let's run it again, and let's see if the result comes out different, because I'm on stage and with the projector and internet, so I don't know. It might not show. Yep, it didn't. Nice. So anyway, yes, demos did. I'm probably running late, so this presentation is available here. -10. -10. I have 10 minutes, OK. This is the GitHub repo. This is me. This is a company I work for called Nearfirm. I am Matteo Collina on Twitter. And this is a company website. I probably demoed a lot of things in this talk. This talk was definitely short of 10 minutes, probably. I would suggest you to come to Daniel Kahn, which is over here, talk, which is go deeper in some of the other concept. And it has a completely different take on this particular, on this subject. And I am definitely open for question if you have. No questions? So I tired you to death? No? Could you understand half of what I said? OK. Yeah. Thank you for being here. Sorry again for not watching for the non-React talk. That was a mishap of yesterday. Basically, yesterday morning, we just, can't come. OK. So we had to rig something up for not having a room empty, which we didn't seem fair. And thank you for coming. And come around if you have any questions. By the way, again, Nearfirm is a consulting company. So we make money selling services, professional services. And yeah! And, so come, if you want any help, come around. We are also hiring. So if you want, if you are whatever. I work remote. I'm from Italy. I work from Italy. I travel around the world. It's a nice lifestyle if you want to. Thank you, guys.